In the beginning, there was darkness, 4,000 meters below the waves. Sunlight has never touched this place. Pressure mounts, the cold is absolute, and life itself hangs by a thread. Yet here, in this eternal night, something impossible is happening. A secret is stirring on the ocean floor. Oxygen is being born in total darkness. Welcome to Let's Discover. I'm Jack Morgan, your guide into the eerie, the unsolved, and the untold. Tonight, we plunge into one of Earth's most unfathomable mysteries, a discovery scientists are only beginning to comprehend. They call it the dark oxygen mystery. What we're about to uncover will blur the line between science and the supernatural. So stay close, because the deep is unforgiving to the unwary. Our story begins in the Pacific's remote Clarion-Clipperton Zone, 13,000 feet down. Scientists set out to measure something ordinary, that how much oxygen the seafloor life uses up. They lowered instruments, sealed chambers onto the seabed, expecting oxygen levels to drop as creatures breathed. But when the first readings came back, they were baffled. The oxygen was not dropping at all. It was rising. At first, they thought it was a fluke or faulty sensors perhaps. Over years, expedition after expedition, the same impossible result kept haunting them. One lead scientist, Dr. Andrew Sweetman, even told his team to throw the sensors in the bin because they just do not work. He was so convinced that the gear was broken. Just imagine it, 5 years of ghost data dismissed as error. But the anomaly refused to die. In 2021, on yet another deep-sea mission, the team tried a completely different oxygen sensor. And once again, oxygen levels jumped dramatically inside the sealed chamber. The crew was astonished. At those depths in perpetual darkness, photosynthesis is impossible, because no sunlight means no plants or algae to make oxygen. Every scientific textbook said that in the abyss. Oxygen only comes from above, trickling down from the sunlit seas. Yet here, they were witnessing oxygen being created, as if by some unseen force. It was as if the ocean floor itself had begun to breathe. In the press of the sub's cabin, someone murmured what everyone was thinking. This isn't how it's supposed to work. So what was causing the rise in oxygen? With organisms ruled out, even poisons added to kill microbes, but that did not stop the effect. Then, attention turned to the rocks. Across the sediment were countless potato-sized rocks scattered, called polymetallic nodules. These nodules are no ordinary stones. They are metal-rich treasures that have been growing bit by bit for millions of years. Layer upon layer of manganese and iron oxides, fused with cobalt, nickel, copper, even lithium, accrete into these dark, knobbly nodules. To the eye, they look like charred coals or ancient fossils. But to the scientists, they suddenly looked like suspects. Dr. Sweetman recalled seeing a deep-sea mining promo calling nodules batteries in a rock. It was meant as a metaphor, a nod to their metal content. But what if it was more than a metaphor? What if these rocks were literally acting like batteries on the ocean floor? The idea seemed outrageous, almost alchemical. Yet, the team had to find out. They hauled up a trove of nodules and shipped them to a laboratory. What they discovered would redefine our understanding of the abyss. In the lab, chemist Dr. Franz Geiger carefully placed electrodes on a single nodule. The readings spiked from 0.8 to 95 volts on the nodule surface, nearly as much as a fresh AA battery. And that was just one. When they clustered multiple nodules together, the voltages added up, just like batteries in series. Enough power to do the unthinkable in seawater and to split water molecules. Run an electric current through water, and you tear H2O apart into hydrogen gas and oxygen. This is called electrolysis in nature. It's the principle behind every industrial hydrogen generator, and apparently, behind the dark oxygen on the seafloor. The nodules were acting as geobatteries, tiny power plants liberating oxygen from the water itself. Rust on metal can create a charge in salt water, and these nodules are loaded with metal. It appears nature had engineered a battery long before humans ever did. Bubbles of oxygen might have been forming on those rocks in the abyss, like fizz in a phantom cauldron. This was the answer, as incredible as it seemed. Inanimate rocks were breathing life into the water. It's a discovery at the crossroads of science and the fantastical, a mineral creation story and abyssal alchemy. But as we grasp this revelation, new questions bubble up faster than the oxygen itself. What does it mean for life in the deep and beyond? If exploring these dark mysteries sends a chill down your spine, then take a moment to support our journey. Because, even in the blackest depths, knowledge is our guiding light. Hit the like button and subscribe to Let's Discover. Join our crew on this descent into the unknown. It's your support that keeps our submersible's lights shining in the abyss. Now hold tight, because the story only gets stranger from here. In the wake of this discovery, scientists are both thrilled and uneasy. The deep ocean has always been a realm of horrors and marvels. We once believed nothing could survive in the sunless depths. Then came 1977, the year we found life at hydrothermal vents. When Alvin's lights first revealed giant white tube forms with blood-red plumes swaying in chemical-laced water, it turned our understanding of life upside down. For the first time, we knew that an entire ecosystem could thrive without a single ray of sunlight. The scene was alien, otherworldly, like discovering life on another planet, right here on Earth. And now, the dark oxygen mystery has thrown another twist in the tale. If rocks can produce oxygen in total darkness, could something be using that oxygen down here? The abyssal plain, once thought barren, is actually teeming with life. Half of the deep-sea species larger than a millimeter live on or around these nodules in this region. Starfish, ghostly sea cucumbers, weird worms, and countless unknown microbes. They cling to the nodules as if to strange black lifeboats scattered across a desert. Are they there simply for the hard surface? Or have they gathered around a literal lifeline, oases of oxygen in the suffocating dark? It's a question that borders on the eerie, perhaps in ways we don't yet fully grasp, but the nodules have been nursing an ecosystem in the shadows all along. We can almost imagine it, a colony of brittle stars patiently waiting for the rock to breathe. A slow pulse of oxygen exhaled every so often, just enough to sustain them. It sounds like horror fiction, rocks behaving like living lungs. But here we are, with data in hand, pondering if the Earth itself has a heartbeat down in the abyss. And if that doesn't send a shiver down your spine, consider what else it implies. This finding doesn't just rewrite textbooks, it stirs up cosmic nightmares and ancient ghosts. If oxygen can emerge without life, just from wet rocks and chemistry, then detecting oxygen on other worlds might not always mean little green men. Picture the dark oceans of Jupiter's moon Europa, or the lightless seas under Saturn's moon Enceladus. Could they too harbor dark oxygen oozing from mineral-rich vents? Could alien life be feeding on a geology-driven oxygen trickle as we speak, hiding beneath ice crusts, never seeing the sun? The thought is as exhilarating as it is unsettling. We might not be able to assume that oxygen is equal to life in our cosmic searches or conversely. But life might find a way in places we once thought impossible, thanks to geobatteries silently toiling in the dark. Now cast your mind back in time to ancient Earth, over 3 billion years ago, before even algae learned to capture sunlight. Our atmosphere was nearly devoid of oxygen. We credit blue-green algae, cyanobacteria, with the first great oxygenation, slowly turning the skies blue. But this discovery forces us to wonder, were there whispers of oxygen before that? Tiny pockets on the seafloor where nodules or minerals split water. offering the first breath to primitive life? One of the lead scientists posed the question outright. For aerobic life to begin on the planet, there had to be oxygen. We now know there is oxygen produced in the deep sea, where there is no light. We need to revisit where aerobic life could have begun. It's a haunting idea that perhaps life's fire was lit not just by the sun, but by the planet's hidden dark workings. Ancient seafarers feared monsters in the deep, but who could have imagined that the seafloor itself might subtly influence who gets to breathe? As with all great discoveries, this one arrives with a shadow. Those unassuming polymetallic nodules are more than scientific curiosities. They are coveted by industries as a motherlode of critical metals. Cobalt, nickel, manganese, copper, lithium. The ingredients of our modern batteries and green technologies are all locked in these rocks. The Clarion-Clipperton Zone alone holds untold billions of tons of nodules, enough metals to power the world's electric cars and gadgets for decades. Mining companies have been gearing up to scrape this seafloor clean, like prospectors eyeing a gold rush beneath the waves. 16 firms have exploration claims here, and giant machines are ready to vacuum up the potato-sized geobatteries by the thousands. But now we realize these are not just lifeless clumps of ore. They may be keystones of a deep-sea ecosystem, possibly providing oxygen to unseen hosts. Remove them, and what happens? Do we snuff out a quiet chemical respiration that hundreds of species rely on? Or do we trigger some unforeseen cascade in the abyss? The thought is chilling. Humanity, and in our hunger for metals, might inadvertently silence the ocean's dark breath. As Dr. Geiger warned, that we need to rethink how to mine these materials so that we do not deplete the oxygen source for deep sea life. It's another layer of horror, a man-made darkness falling over the creatures of the deep by robbing them of an oxygen trickle, which we never knew existed until now. This confrontation between human progress and deep-sea mystery feels like the plot of a sci-fi thriller. The International Seabed Authority is drafting rules for mining, while over 30 countries call for a moratorium to pause and study. Will we listen to the warning hidden in those rogue oxygen readings, or charge forward and possibly disturb an ancient process we barely comprehend? The abyss holds its breath, as do we. The ocean's deepest floor remains one of the last truly dark places on Earth. Dark not just in light, but in knowledge. We have now seen that even here, in the Stygian black, the Earth can surprise us with a spark of life-giving air. Dark oxygen, the very phrase sounds like a paradox, a riddle from a sailor's nightmare. Is the seafloor alive in ways we never imagined? Perhaps the planet has been playing a long game, keeping some oxygen in its back pocket, for those willing to venture into the depths to find it. It's a reminder that as much as we cast light into the abyss also looks back up at us, unblinking, with secrets in its ancient eyes. As we conclude our descent tonight, consider this. We went looking for death and decay on the ocean floor, but found a hidden pulse of life instead. A cycle unbroken for millennia, now flickering under our curious gaze. The deep sea has given us a gift and a warning. Whether we witness them or not, there are forces in nature that operate in silence and darkness. And when we do uncover them, we stand humbled, a little fearful, yet in awe. If you've enjoyed this journey into the unknown and you're hungry for more, don't forget to like this video and subscribe to Let's Discover. Join me and we'll venture together into darkness again, chasing whispers in the water and echoes in the void. After all, the deeper we go, the darker it gets and the greater the discovery. Until next time, remember, not all secrets can stay submerged forever. This is Jack Morgan, signing off from the bottom of the world. Stay curious, stay cautious, and good night.